That's there. But oh, it which was like, so what happened? What the- Left. Just getting over. Okay. And all right, so we're talking about rap. Um, so the first thing I wanted to do is just kind of talk about kind of what this means really quick, and I'll show you guys an example. Give me the playthrough for this week. But so the word rational has a root word to it, so what word for rational? Ratio. So, and ratio is just a fancy word for fraction. So a rational function is literally a function that looks like a fraction. So specifically what you're going to see, it's going to be a function that looks like a polynomial. So you'll have some sort of polynomial on the top. You'll have some sort of polynomial at the bottom. So those things we just saw, although we won't have as complicated ones, one of those is going to be on the top, one of those is going to be at the bottom. That's a rational. So a fraction is a ratio with just a number on the top and a number at the bottom. So we're just basically, we're just sizing that idea up to say that we can have a polynomial. So for instance, a rational function might be something like 3 over x squared minus. This is a rational function. Polynomial top, polynomial bottom. And what we're going to do this week is we're going to do the same thing. So we're going to try to graph this thing. So I really want to take a similar approach to last week, where kind of we spent the first day experimenting and figuring out stuff about polynomials, about the graph of polynomials, and then we spent the second day like identifying those key things as an alternative way to get the graph going. We're going to do the same thing this week. So I want to start off with, let's experiment. Let's try to get a graph going. And then in doing so, you're gonna see possibly some weird things or just different things that kind of show up. And so then we'll break down the graph, we'll break down those weird things, and then kind of talk, and then, the second half will be, let's identify those things first. So anyways, I don't want to do too much here. I do want to do the, what do you call it, the discussion that I gave you guys though, so that is gonna be really important. So before I send you off to try to graph this, on the discussion, I had you guys do 3 different calculations. 0 divided by 6, 6 divided by 0, and 0 divided by 0. And so, well, actually, I didn't have a chance to look at this beforehand. So how many of you guys didn't do the discussion? No harm, no foul if you did, but it's really important that you do these before I talk about them. So so that's why I'm asking, how many of you guys didn't do the discussion? Oh. All right. Let me give you guys, so if you've already done it, just hang tight literally for a minute. But if you haven't, I'm gonna give you just a minute to do these kind of. Oh, interesting. And that would be, I think, the initial thoughts will go with that. If you're not, I won't try it. There's a big reason.
You didn't.
You,
What's that? Oh, okay. All right, it's changing. If you look at the thieves.
alright, so let's see what y'all are getting. So 0 divided by 6. What is that?
Yes.
That is 0. Before we go on to the others, so why is that 0? So how did you get that calculation? So this sounds like a weird, simple question. It's actually a really important question. So I'm gonna dig for a second to get you guys to really answer this. So like I know everybody knows it's 0. So try to go in your mind, literally go in your mind to when you figured out that it was 0. Maybe you just calculated or whatever, but you could tell me that. But go into your mind and figure out what came before, when your mind said that the answer is 0, what came before? What was the work before?
Then it's possible that 0 could go into 6.
Okay, so you're saying it's possible that 0 kind of goes in. Now, the way this reads is actually the opposite. It's 6 going into 0. But yeah,
It's not like 0 divided by 6.
that is, so when you say 0 divided by 6, the alternative way to say that is 6 into 0. It actually, yeah. And it's because in English, word like into switches the object and the subject of the sentence. So when you say into, when you say 6 goes into 0, it's the reversal order of what you think. So, because English is a crazy weird language, honestly. So I say that as an English speaker, we have a really weird mash of crap that makes up our language. So, let's see. Okay, so in your mind, how did you know that this was C? Before you told yourself the answer, what did you do? So, better question. Let's do something else first. So you can kind of see why I'm sticking with this room. So 36 divided by 9. What is that? Okay. But again, so now go into the little thread in your mind.
How many times can 9?
Okay. And so you ask yourself, how many times can 9 go into 36? How do you answer that in your mind? What's telling you that answer? Multiplication table. Bam, multiplication tables. So occasionally some people actually do division, but what most of us do is you asked yourself 9 times what gives you 36, and you told yourself 4 because you had multiplication tables. Good. So that's what I was digging for, and I guarantee you. So the reason I'm digging for that is, so the surprising thing about brain is all of y'all did that, but at some point, like your layers of thinking, like you basically just buried it. Like you just don't think about what you're doing. And it's really important sometimes to think about how you think through things and what you're doing, because that actually reveals patterns for what things are true and what things aren't. So that's what your mind did, is you asked yourself 9 times what equals 30. So humans, we almost never actually do division. We do backwards. You ask yourself what multiplication. So that's actually. So when you did 0 divided by 6, you may have just said 0 because you thought it was the answer, but more likely you kind of, again, somewhere down in the register, you ask yourself 6 times what gives me 0, and 6 times 0 gives you 0. So this is correct. Now what about 6 divided by 0? So 0 times what gives me 6? Yeah. So the fun thing about this is not possible, because when I ask myself 0 times what gives me 6, 0 times everything is 0. So this is actually not physically possible. Another way to keep thinking about it, multiplication is, or to think about it, multiplication is repeated addition. So you kind of also, one way to think about it is, how many times do I gotta add 0 together to get 6? And it never works. 0 plus 0 plus 0 plus 0 plus 0. However many times I do that, it's always gonna be 0. So this is not possible. They'll often say it does not exist or something like this. But this is not just there is an answer, but we don't know it. This is there is no answer. Then I think the funnest one, 0 divided by 0. So 0 times what gives you 0. So, and that does work. 0 times 0 gives you 0. Is this the only answer? So, surprisingly not. So maybe again, so when I get you to do a calculation, or I give you an equation and I say find a solution, you're expecting there to be 8 answers, or maybe a couple answers, but like something you can count. These are the things. These are the answers. Problem here is 0 times 0 is 0, sure, but so is 0 times 1. So 0 times 2, so is 0 times -3, pi, whatever I want to put there. The problem is 0 times that number is still 0. So technically, this doesn't have an answer, this has an infinite number of answers. So it's sort of the opposite of not possible. So not possible is saying there's no answer. Here I'm saying actually everything is an answer. But if I say everything is an answer, have I really given you an answer? Have I told you what it is? So there's kind of a problem so there's things like this in mathematics, you'll see this actually keep popping up as we go through the rest of algebra, and if you went farther with math. This keeps popping up. You keep on getting these weird scenarios where the answer is everything is an answer, but everything is an answer is not an answer, because I haven't told you what it really is, right? So this is not 0, this is everything. But let me also give you the term they use for it, because it's I think a really good term. So the term they have for this is indeterminate. But they're literally saying you can't determine what these. But I can't tell you the ones and these.
So would undefined still be accurate? Because like in what I've learned in school is like whenever there's a 0 as a denominator, you just always say everyone.
It's so undefined. So undefined is what they use in a lot of textbooks, but part of the reason they use it. So the short answer to your question is half yes, half. Okay. So it's undefined is their standard way of saying both of these, but it's really actually too broad of a term. Undefined doesn't mean there isn't an answer or that everything's an answer. It just means I'm not telling you what it is, right? Like, which isn't really what we're saying here. So they use that as a shortcut, honestly, in textbooks and on calculators. so that we have an output to read, but it's not really, okay, so, yeah. Okay. So. If I have a zero on top, some number on the bottom, I get zero, but if I got, so if I get these other scenarios, it's either not possible or indeterminate. Alright, so that'll come up, so notice that rational functions again, they're fractions. So once you plug in your x values, you're gonna be doing some number divided by some number, you're gonna calculate the top, calculate the bottom, which means you might possibly come across these scenarios. That's why, it's one of the reasons I wanted to do this first, is these three scenarios are now gonna possibly come out of our calculations when we go to graphs. So. Okay. With that in mind, go ahead and see if you guys can get a graph going. So I'll start there first, give you a little time to get a table going and see if you can get a graph going. Yeah. Oops. Oh, well, yeah. No, we do. For one. Also, that's.
He was two, right? That's what I got.
There's a time.
Yeah. It's this. That's all I'm saying, because one was this four, and one is where it's minus one is zero, and then minus two says that's four divided by negative two. It's like negative two. Knew it. See? Ah, I just did it. Let me try two. Two, three. Two squared. So two squared plus minus two is two. That's on 1.25.
I was thinking because they can be able
So it is
to.
It's also clear. There's a plus word minus. That was a plus. And then
That's not something that you should kind of knowledge.
you got to do it. You know, you know, 87. Okay, let me try you. I'm trying to see. Error. You. Consumer. Even with fun. That error from work. Do. What?
Maybe like negative one.
Whatever. Alright, when you write it down, you write it down, write it down. You only look once, I'm just gonna write down. Negative what? I mean,
So that's the problem is that they will explain some close to the problem. So we. This is.
That's one. So we have to grab. So we can move.
Try it. Actually, you try, I'm always gonna figure it bad.
But also make sure. That's all you gotta.
Oh, wait. We're writing another. Take out. I. You're about. That's money. Or the ass band. I will bring them in. You do. So you really voted for stuff that's really good. What do you get good? Because it doesn't happen. Thing of error stuff. Yeah, it's in the filter. Exactly. What is this? Do you know what I mean? Awesome. What? Don't do what? This is how you do it with it. It'll be good. Boom, right? Then use this line. And found. No way. This. Here. It doesn't just move. I'm looking at tripod. So it's the best read. No way it's more point than I don't know what I mean. Oh, the lights we go. Sorry. I think we've come to- But this is whatever. What they come? You get. Oh, you falls. You see what they're just like.
Yeah, that's weird,
All my options.
but it is 371, since we have those for asymptotes, so.
You get it was. 3, 4, 5.
Well, and the horizontal asymptotes are weird because they only apply at the end graph, so the middle graphic puts it, so that's just. But the vertical asymptotes are absolute negative. On a horizontal, but the vertical. Yeah, they're technically. Technically, you see, it's cross. I see that this would bring it's technically cross, but this would. Yeah.
I'm good. You are too. You are in.
Part of it's because we'll get to it by the end of the meeting, but all I'm getting was those. From like mathematically they come.
There.
Very possible factor, of course, this come from. Just the way like calculations work, fraction. So
So why don't you have a.
concepts fractions and implies larger versus solution. That's possible.
I just want to see what it looks like. Stop it.
Alright, good. So let's look at what y'all get the data. A lot of y'all have values, but either don't have a graph or start doing a graph and then I'm like, wait, something weird is going on. So the thing is, that's where I want you guys to get to, is there is something weird going on with these graphs that honestly you don't get with almost any of the other graphs now. So let's figure out what that weird thing is.
It's just me. What
All right, so what X values did y'all choose? Yeah, so we can start with our usuals, -2, -1, 0, 1, and 2. So we'll start with those, and I want to see if you guys went outside that. But with -2, what did you get? Yeah. So -2 should be 1/4, yeah, should be. So the first weird thing here is that we talked about last week, the polynomial naturally give you really large numbers. Because rational functions are a fraction, you're naturally gonna start getting some pretty low fraction. What about -1? 2/0, and so going back to what we just talked about, 2/0, which one of those scenarios? Not possible. So we wanna write that. So you can either write not possible to make it, just to save myself some space, I can write does not exist, but just whatever is the decline. What about 0? 3/2. Yeah, 3/2 or -3/2. What about 1? Or yeah, 4/2, which divides out to -2. And what about 2?
5/3.
So this is another does not exist. Alright, now once you got here, so first, before we talk about other numbers, what was weird about these results? Everything, okay.
Right.
Yeah, so and we can even graph it out, you'll see, so the first thing is visually, it's gonna be sporadic, whereas we're used to seeing some sort of shape, sort of, either a straight line, a curve, but it's like you could see it plot out as you do it. So that's the first. Also, we've never seen does not exist, the results have to interpret what that looks like. Because notice what's happening here is what I'm saying, -1 is impossible, which means there is no point I can mark it. I don't have a y value. Then there is no point I can mark it. So what does that mean in terms of the graph? So let's start.
It looks like it's so.
-2 gives me 1/4, so something like that. -1 is it does not exist, 0 is -3/2, so -1/2. 1 is a -2. Then 2 is it does not exist. So this is again, like he was saying, so first of all, quadratic. So how do I even interpret that? But also, let's talk about this does not exist. So like I said, it's not a point, so I don't have to lie about it. But also what I'm saying is I literally physically can't plug in a -1 or 2 to the graph. So I need to find some way to visually show the reader that I can't do the thing at negative, can't do the thing at 2. And so the way that they show this, they draw in what's called a vertical asymptote. So they draw in a vertical dotted line that my point to the reader is I'm basically saying, my graph doesn't exist here. There's a break in the flow of this graph right here, which means that my graph is actually never going to cross or touch this line. Because so think of this like if you're into sci-fi, so think of this like a ribbon in time, or some sort of a void in space, where it's like that little single infinitesimal line like that, but that doesn't exist. Everything to the left of it will exist, and everything stuff to the right, but not there. And so so they call this, like I said, they call this a vertical asymptote. So just like when we did the quadratic functions and we had the line of symmetry, they're going to ask you to give an equation for this vertical asymptote. So the equation for a vertical line is x equals, and just whatever that number is. So in this case, -1. And this means we're also going to have a vertical asymptote at x equals 2. So at x equals 2, I can draw the same thing. So we got 2 vertical asymptotes to this graph. And again, what I'm just trying to communicate to the reader is graph don't do graph stuff. Like it doesn't do the thing right here and right here. Everywhere else, this is it. All right. So that you wouldn't have had there, you would have had no way to know that that's what you need to put on the graph, but now you know. With that and the visual of these disjointed points, so did anybody go and start picking other X values? Try to put this. Yeah, so, y'all in my classes are better than the other, out of the three, college algebra classes I had this semester, y'all are much better at like, when you see this doesn't make sense, you can start. So what other points did you? -3 and a +4.
Well, like, yeah.
Oh, 3 and 4. Okay, perfect. Yes. Okay. What did you get for -3?
Very good, so,
Which is 0. Good. So that's going to be 0. What did you get for 3?
6 over,
6/4, which was the 3/2. Good.
and then 7.
And then 4 is 7/10. Good. All these calculations are correct. That's perfect. So at 3, it's going to be 1.5. At 4, it's going to be 7/10. So your best guess at 0.7 there. This gives us a little more to the graph. Did anybody pick any other side? Yeah, they. What did you get for -1? It should be some really small fraction. Yeah, they do. Yeah, -1/18. So we'll fill that in. But -4, it is -1/18. So something just crazy close to the x-axis. So then the question is, now that we have a little more, it still looks disjointed, but what would y'all say? How would you draw the graph? Is there anything that visually makes? But they would. So you're saying a bunch of parameters. Yeah. So maybe let's work on the left side. So I'm gonna basically, visually in my mind, I'm gonna split this graph into 3 pieces, because that's what our vertical asymptotes have actually done. We sort of have a region over here, we have a region in the middle, we have a region over here. So a couple people noted that actually with this graph, one of the things you're gonna see here that we don't get with other graphs is this graph is essentially 3 mini graphs. It's 3 pieces. And the pieces just don't touch each other. So on the left, kind of have these 3 points. So we see kind of a gentle curve there. What do you think happens between -3 and -2 here? Kind of you get closer to this x-axis. What do you think happens to the graph? Yeah, and y continues to go up because maybe it could go down. Why? Because we seem to see kind of a gentle curve there. So that's good. I think for now we'll kind of leave that. That's a good reason. So it seems to go up, but again, it's never gonna cross this line. So the fact that you know that it never touches or crosses this line kind of tells you the rest of the shape over here. It's that it's gonna keep going up. Actually gonna get closer and closer to that line, but doesn't cross. Now, the better question is, what do you think happens as we go farther out? Negative. Say it again. You think it kind of goes down? Okay. And the surprising thing is it doesn't, so, and that is, yeah, so this is the harder part to describe Bell's graphs as far as why it doesn't do that. And basically the best I can tell you is if you start plugging in other numbers, like if you plug in a -5, well, the first reason I can tell you, you'll get something like -1/14, so that's about the same thing. But as you go farther and farther out, these points are gonna get smaller and smaller, but they're gonna stay negative. So they're gonna be negative fractions. They're really, really close to 0, but not quite. So what this graph does from here is it actually goes out and then goes back in and just. So it basically treats the x-axis like the axis. So it gets closer and closer to the x-axis as a line, but it never actually. So. Could you determine that? Yeah, but we'll get there, because most people are nowhere near that. But but so by the end of Thursday. So so these graphs have vertical asymptotes, just like they have vertical asymptotes. Most of these graphs ends up having a horizontal line that on the ends of the graph it never crosses. And so on this graph, it looks like on the left, basically my horizontal asymptotes is the x-axis, which the equation for that is y equals 0. So on the left, it's going to get closer and closer to the x-axis, but crossing. And so this is a little different shape than we've seen before. It's not that so it's not that y'all's y'all's guesses were actually really, really good. Let's face it, almost everything you've seen is kind of good. So part of it works. And so this is the first time we're sort of getting a real different shape. This is some stuff our graphs. Let's talk about the right side then. We'll get back to the middle. So then what do you think on the right side? Same, yeah, so we seem to again have a curve here. We know that it can't cross x equals 2, so that forces it to go up this way. We now know that we have sort of this horizontal asymptote, so on the right end, it's never gonna cross y equals 0 either. We also, we'll kind of talk about how to figure out that we know this, but right now we only have one x-intercept. But we also kind of know that this graph can't cross the x-axis, or doesn't have an x-intercept anywhere else. So it's going to go out like this. Yeah. So it's stated above that. And his comment is really good. It brings up a good point of, so for this first go through, for kind of experimenting our way through this graph, there's stuff like that, the fact that it's always positive, we actually don't know that. We would have to be working on energy in existence that keep doing that. So we're gonna do this and then we're gonna redo it, but I'm gonna show you guys how to figure those things out. Figure out where this thing is positive and negative, and how you know that it never stays long. So, good. So the last thing to figure out is the middle. So we're going to use a bit of the same bit of logic we've been. So right now, what I see sort of a curve here, and it could this curve. So maybe this curve is like an S, like you guys were saying. Maybe it's a U. Maybe it's some other weird thing. We've got to figure out kind of how to know which one's which. We do know what we do know. So logically, what we do know is it can't cross x equals -1 and x equals 2. And right now I'm going to say we also know that there is no other x-intercept. So it doesn't cross the x-axis again. So with those two things in mind, if it can't cross here and it can't cross here, what is this shape going to have to look like? It has to be a U. So it forces you into this being a U, but this is not a symmetric U like we were used to. So this is some oblong U, but nonetheless, there. Well, I guess none of it doesn't have a stride. So like if you plugged in, so to get an idea of this, like if you plugged in say -1/2 and 3/2, plug in -1/2 and calculate that out, it's going to end up being -2. Then I think 3/2 ends up being 6. So it's like you kind of get this point here, and then you get a point way down here, basically. And so, but actually, you're going to get nothing. So it doesn't mirror on the top, it also doesn't mirror. So this does get us to graph. On a scale of 1 to 10, 10 being tooth pulled out of your mouth, 1 being a bubble bath, how excruciating was this to get this graph? 6, 10, 7. Was this harder to get this graph than any of the other graphs we've done? So it's a lot harder than any of the.
So it's not that it's, again, it's never that it's impossible this way, but you will notice with rational functions, you're gonna get a lot of this. So if you try to get these graphs just by doing the table, it's a lot harder than the rest because we have these does not exist. We have to sort of guess at the horizontal asymptote. We have a lot of fractions. Like on this, you would have tried to possibly plug in half, three, or call it 3/2, but the fraction word. So it's just a lot messier. So what I want to do is I want to, the rest of this week, I want to show you guys how to find some of this information first. So this does not exist. Your X-intercepts, the horizontal asymptote. So the thing is, if we can find all that first, then you'll see all we got to do from there is just pick a couple X values, fill in pieces, and then use the same logic. Just we know that things don't cross vertical asymptotes. We know they don't cross horizontal asymptotes at the end of the graph.
Yeah. Unity has got like zero.
Yeah. And I'll honestly, so this is a really good question because the way that I got y equals 0 is I'm looking at my y values, which is not indefinite, so it doesn't definitely tell you. But how I got the y equals 0 is I noticed that, so after this -3, 0, I noticed that, so -4 was a little below the x-axis, and then -5 was about the same. And then if you plugged in like a -10, you would have got something that was actually a fraction that's even lower, but still negative,
That doesn't count.
so it doesn't cross. And then if you plugged in 100, same thing. So when I see that pattern, that's how I'm getting y equals 0. So then the same thing on the right, and I see the same thing, except for it's positive, but you keep getting positive fractions, get closer and closer to 0, but the end. All right, so let's redo this, but this time, like I said, let's figure out a way to find some of this information first, so that we have to plug in all of this. And the way we're gonna do this, so another reason I had you guys do this discussion is that these three scenarios are actually gonna guide us. It actually, pretty much, it'll get you everything except for the horizontal line. These three scenarios actually guide us putting this graph. Same. And the reason that I say these three scenarios guide us, because let's think about the first scenario. First scenario is scenario where you have 0 on top of the fraction, some number on the bottom, it gives you 0. But if I get 0 out of the function, my y value is 0. If I plug in something for x, I get a y value of 0. What is that on the graph? So think about this. If I plug in something for x and I get 0 for y, what is that? That's an x-intercept. So you guys know this. So every x-intercept with the projector like this. Plug in something for x and I get a y value of 0. So what I'm saying is, if I have a scenario, if I have an x value that gives me 0 on top and something else on the bottom, then I automatically know from my graph that that's an x-intercept. I don't need to graph it to see it. I know that it is. So this is an x-intercept. So the idea is, what if I did something to this? Not picking random x values, but what if I did something to this to figure out what makes the top of the fractions here to begin with? Then I would automatically have my x-intercepts. So that's what we could possibly do first, if we could figure out how to find what makes the top.
And I already know that that's X. The second scenario I gave you guys was I plug in something for X, just like you guys did when you were doing the table, and it made the top something, but more importantly, it made the bottom zero. Something divided by zero. And what did that give me on the graph? Does not exist. Zero. Does not exist. And what did that give me on the graph? So if I could identify what makes the bottom of my fraction zero, to begin with, then I have vertical estimates. And I can know that before I even build the table. This is vertical estimates. And then the third scenario didn't show up in this graph, so I'll kind of tell you guys what it means. But the third scenario is some X value that gives me zero on top and zero on the bottom, or there's sort of an overlap. And this was indeterminate, which still means I don't have a Y value, right? Because I'm saying everything is a Y value, but that doesn't give me a point. What it does give you in the graph, though, this gives you a hole in the graph. So this is going back to those open circles that we did at the beginning of class. That actually gives you an open circle in the graph. So literally a hole in the graph. So if I could figure out what makes the top zero, what makes the bottom zero, and then from there I could see what number makes both of them zero, then I could figure out x-intercepts, vertical asymptotes, and holes in the graph before I even do anything else. And so that's what we're doing. We got to figure out what makes the top fraction zero and what makes the bottom fraction zero. And looking at those, so you don't have to give me like an answer, but in general, how do I do that? If I set the top equal to zero, set the bottom equal to zero, what do I do? Solve for x, which may include some fact. Or you may just be able to solve for x. So that's the first thing that you got to do on this. So better, I'll see if you guys think it's better, but I think a better approach on B is we're going to be picking x's is let's set them equal to zero and solve them to begin with, and then figure out. So I want to give you guys a couple minutes to do that. But go ahead for both of these, set them equal to zero and solve. Right. So the top one we're going to be doing real layer three. And people. I'm trying to we over. We're making things. Can you redo it? Make a thing. That's. That's usually watched them. Let me ask you a question. How much for this pencil? It's just. Which was the pencil? Oh, hell no. I don't want it no more.
Good reasons, facing that. I'll go some little eight days. No. But again, you like smooth very basic. Yeah. Just try it. How much for that pencil there?
No, it's not that,
It's like really ask for a little balance from the point for it, and then you'll see like. It's not even good. Just see. John with it. You can solve this, so you solve it.
Who's the red one?
What? Everything. So.
well,
All right.
let's see where y'all go with this. So on the top, what makes the top zero? How do you solve? Yeah. So you notice on the top, x plus 3 equals 0, that already kind of gets me there. So that's x equals 9. And so let me actually, where did I put it? Let me label this. So we're saying on the top, we're saying what makes the top of the fraction 0 is -3. Now, what about the bottom? Try to take me through the process. How do you solve that?
That's it.
Yeah. So we're gonna need to factor. So notice with this requires that you end up doing a little factor. And it's just because that's what you see there. So we have x squared minus x times 2. To set it equal to 0, I now can't get x by itself, I need a factor. And what did y'all end up with on the factor?
X minus 2 and x plus 1.
That's gonna be x minus 2 and x plus 1. And we're gonna set those equal to 0. So then for the bottom of the fraction, what x values get negative? Yes, you got 2 and negative. So now let's go fill in, you'll see it literally we're just gonna fill in our three scenarios. So first scenario gives me an x-intercept, whatever makes the top of the fraction zero. What makes the top of the fraction? Negative. So that's the x-intercept. Second scenario, something over 0. So what makes the bottom line fraction 0? 2 and -1. So those are my vertical outputs. X equals 2, x equals -2. Again, you do this first, you already know that with the graph, and you can, we can write that in on the table. What this function doesn't have, but again, something that you'll need to look for is an x value that makes both the bottom and top clear. So essentially, if you have some sort of overlapping value, then that's going to give you a hole in the graph. Okay, so we already know this about the graph. The next thing, so the other thing that I kind of talked about on the graph that you guys asked a good question about was horizontal asymptote. I want to talk about how you figure out the horizontal asymptote. The horizontal asymptote though has nothing to do with it. So factoring, setting your factors equal to 0, that'll tell you the x-intercept, vertical asymptote, and it'll tell you both. But it doesn't tell you horizontal asymptote. I'm gonna be that hard. So separate from this, let me. Horizontal asymptotes. What horizontal asymptotes are about, and what leads to them, they come from this calculation you're making, you're plugging X values, creating that. So, like you guys, like the good question that was brought up, what I'm seeing is on the left, I keep getting these smaller and smaller negative numbers, right? So I keep getting a fraction where the top's staying constant, the bottom's getting bigger. And then the same on the right. One was negative, one was positive. So if you think about the polynomials that we have on the top and the bottom, so like the x plus 3, what is going to contribute most to that calculation? X of, and what do you say?
It's telling,
Say,
it's telling.
well, it's telling you like if this is low numbers, yeah, but what if this is like 1,000? So if x is 1,000, is 1,000 the bigger part, or and even if this was a 500 or a 100. So as you get to, this is where we're talking about, as you get to the ends of the graph, the left and the right end, as your x values get bigger, negative and positive, for x plus 3, the x is the bigger part. So that's going to drive the calculation. What about the x squared minus x minus 2? So not for low numbers, but if I'm plugging in a 10 or 100, etc., which one of these terms is going to be much larger?
X squared.
The x squared. So basically, for each of the polynomials I see, the larger power, so they call the quotient. Well, yeah, we'll get to quotient here. Yeah. But when we were talking about polynomials last week, there's some vocab we used for it. The leading term, so they called it the leading term with the highest power. That's going to drive our calculation. So our fraction, when I start plugging in big positive numbers, big negative numbers, it's going to look like whatever x over x squared looks like. These parts are not going to change. So the leading terms, the largest powers that agree, drives your calculation. So if you think about x over x squared, if I'm plugging in large numbers, which one is automatically larger? X squared. A lot larger, actually. So if I plug in 100, 100 squared is 10,000. 100 is only 100. So I'm going to get some pretty small fractions just because x squared is large. So if your leading power on the bottom is bigger than the leading power on the top, automatically your calculation, your fractions are going to get closer and closer to zero. So automatically, let's see. How do I want to write this? Power on top is greater than the power on the bottom. And automatically, that tells you that y equals 0, or the x-axis is your orthogonal. So for horizontal asymptotes, what you have to do is you have to look at the largest powers, top and bottom, and the way they compare to each other will actually tell you what your orthogonal is. All right, well, so let me give you a scenario that obviously we haven't seen them yet. Sometimes it's not good to know something ahead of time, like to know like this second scenario and then see an example, because your mind automatically just says, okay, that's the thing, but then it never really learns. Just assigns a value. It says this is it, and that doesn't stick. So sometimes this is why I do sort of this method of teaching where I get you guys to do something first and then we figure out the connections, because that actually sticks better. Yes, so I'm saying all that to say, I don't know if I want, maybe I don't want to introduce.
But.
Um. We only have 12 minutes left, so the main issues haven't done. Yeah, so I will give you on
Thursday, I'll give you guys more about horizontal asymptotes, but that's actually why we ended up with y equals zero, so our horizontal asymptote for this one is because power on bottom, lower power on bottom, greater than power on top. But yes, let's start an example where we have. Let me change this. So let me give you all another one of these, and the first thing we're gonna do like this, we're gonna figure out x-intercept vertical asymptote. Again, the first thing we want to do is let's set it equal to zero. In this case, we have to factor them, but figure out what makes the top and bottom zero, and then figure out those main pieces. So go ahead and take a second to do that and figure out x-intercepts, vertical asymptotes, and then sort of set yourself up for the third part. Yeah, I mean, it's fine. Whatever you want to do. I need. Guys, we'll have, to stop this round, because this needs to be positive instead of negative, make this kind of match that scenario. I think because we just have a couple minutes, we will do this, so we'll leave. But next time I kind of actually want to finish, I want to finish up recreating that first graph, this, and we'll work. So, you gotta work the see you guys on Thursday and finish this up. Yeah. All right. Thoughts? Yeah, yeah.
But the way I learned it, so whenever you were explaining it, this was a little confusing to me.
Okay, yeah,
I don't know if you ever heard it, but they say bottom heavy and top heavy.
yeah, you can do that.
I think-
that's good verbiage too, yeah.
But yeah,
Yeah, okay, yeah.
that's what.
Yeah.
But that's
But no,
because I always forget the less than and more than. That's just me. I'm sure other students might find it this way, but that's just how
Yeah.
I remember it.
I think it's good verbiage for
Yeah.
it, so yeah. But yeah, I like this, because it's like, this is actually what science and engineering is about, is you analyze the scenario before you really put it together.
Yeah.
You use that.
And that's what I always like. What I remember is I always whenever I write like that,
Yeah,
I just put a note every time I solve for I just do zeros on top,
zero in
all
on
right,
bottom.
vertical,
Yeah,
asymptote,
okay, yeah.
and then I'll put like this, and then I'll write horizontal.
Okay, yeah.
That's just how
No, that's a little, yeah, I see that, like visually, that kind of gets you everything, yeah. Now that unfortunately, if I did something like that, most students wouldn't be able to, like, they can't abstract it like that, so, yeah.
Yeah, you kind of have to like understand it.
Yeah, it's almost like its own little code essentially, so it's like you're creating the code as you're creating.
But yeah, whenever I remember whenever I first saw this, oh that's another. I remember when I first saw it, I was very confused. Like when I first saw it.
Yeah, yeah, that's also usually why I like.
Cause it can be a little
Yeah.
overwhelming.
So it's like, that's why I like build it up.
Yeah,
Because it's only after you see the connections, then you can code it.
I like that because a lot
Yeah.
of people are visual learners. I like that you provide the graph.
Yeah.
And I feel like I would have learned quicker if I was taught like that.
Yeah,
Because when I was taught like that, they just gave me a rational function and they were like, okay, solve for zeros.
yeah.
So it was, yeah,
And then you're like, what?
I didn't
Like, what is?
I didn't understand
Yeah.
what the point of vertical asymptote was, so it was confusing. speech, but I think we explained what it is.
Yeah, thank you. What's your major again?
Cybersecurity, actually.
Okay, yeah.
And I want to go into that.
You're going.
But I always like math. Math is like my strong subject. It's just like whenever I take a test, I'm just a bad test taker.
Okay. It's probably just anxiety.
Yeah, like they said, like, I
Yeah.
think that's what it comes down to.
Yeah, so,
Cause I know it, but then whenever I just get it, it's
yeah,
like on the homework I'll do fine. Like
yeah,
also because it's open resource, like I can
Yeah.
look at my notes.
that's true. Well, the other thing too is I mean, I don't know, I'm sure I've said it that day when I was talking about the anxiety, but the two tricks that I found is one, don't study the day of, because you're just worrying yourself out of thinking through it correctly.
Yeah, I think I do.
Yeah, honestly, like
So I studied right before the test.
Yeah, and so in college I started doing that. I just started the night before. I was like done. I'm as good as I'm gonna be. I'm not even gonna think about this before I walk in tomorrow. And then I started doing as well as I could on the tests. The other thing is like so you just gotta lie to yourself. So like you said on the homework, it's just a bunch of questions and you do fine. So you gotta lie to yourself. You gotta tell yourself that it's not a test. It's just a bunch of questions because then you won't have anxiety.
Yeah, you didn't tell me. That's a good way to.
Yeah, that's a really good.
Like oh, it's just a normal assignment.
Yeah, it's just normal.
What I mean, too.
Yeah. Because technically, ultimately, it is just a normal assignment. It doesn't matter that it's worth a larger percentage of your grade.
It's the same assignment that was on the questions.
Exactly. Yeah.
It just says test on it.
Yes.
But it's crazy how our mind does that.
I've almost thought about. I don't know. It's actually hard not to because of the way the classes are structured. But I've thought about not writing the word test on it and actually doing a psychological, sociological study. Because I guarantee you, if you don't see the word test, people do better.
Just don't tell them it's a test.
Yeah.
And then tell them it's a test. Give the same exact test to a different class
Yeah.
or something like that.
Yeah, just be like, today we're gonna work on a bunch of questions. Here you go.
Yeah.
You know, like, yeah.
It's crazy how
Yeah.
it's just that word is true. It trips you out of your mind because you start overthinking, especially like me, I care about my grade a lot. So that's why I get stressed out because that's the first thing I think is, oh, my grade. I'm gonna do bad. So, or not that I'm gonna do bad, like I'll try my best. But if I see one question that I don't know, it just throws me off completely.
Yeah.
Because I just think about my grade, like,
Yeah.
oh, if I miss one question, then it's
Then,
gonna bring my
yeah.
grade point average down by 2 points. So and then that's all I think about in my head, so it just overtakes.
Yeah. That's exactly what. Yeah.
But yeah,
So just a bunch of questions.
yes, much better. Thank you.
All right, you're welcome.